Hi, everybody. I'm pleased to have you at this webinar, where we're going to be looking at the use of MapleMBSE for managing domain-specific stereotypes with the SysML models. And as Rochelle has mentioned, I'm joined on this with David Hetherington from SSI and Brownie Mohan, who is the MapleMBSE product manager, who will be on to answer any questions that you might have as we go through this. So before we get into David's presentation, I just wanted to kind of set the context. First of all, what has motivated us from MapleSoft to develop tools in the systems engineering domain. Traditionally, our products have been very much on the analysis and simulation side. So Maple, has been our flagship product for 30 odd years now. MapleFlow is a relatively recent tool for doing calculations, engineering calculations. A few years ago, we launched MapleSim, which is a multi-domain dynamic simulation tool that allows our customers, our engineers, to develop early stage virtual prototypes of the designs to make sure that they actually comply with the goals of the system design, which kind of led us into the world of systems engineering. And this is really what we're going to be focusing on today, is MapleMBSE as a tool to help to facilitate the communications between all the various groups that are involved in the systems engineering process. To just give you a bit of an introduction to SSI, certainly David and I have been working very closely together for the last few months to really establish a partnership between the two companies, where we certainly see the capabilities of SSI being very important for us and our customers in terms of providing deep MBSE and digital transformation expertise alongside our modeling and analysis offerings. Specifically, in the context of systems engineering, to be able to provide support and guidance to their customers and our customers to introduce MBSE processes, and alongside that with the expertise in MBSE tools and also development of application specific tools for supporting MapleMBSE. And one of the important factors for us is that they are a US-owned company with the necessary clearances to get us into aerospace and defense contracts. I'll remind you of their email, their website later on, but it's systemxi.com if you want to find out more about that. So why are we working together? I think largely because we are seeing a major shift within our customers in terms of what's described as the digital transformation of the engineering processes, which largely is talking about removing the silos. So the natural siloing that typically goes around some functional group or a process, and to be able to allow these different groups to be able to work together a lot more smoothly. And certainly we see that certainly in the systems engineering world, where it's very critical for all these various groups and stakeholders to be able to work together, it's really important that we can help these organizations to do exactly that. And that's really our motivation. For MapleMBSE, certainly when we got started in the systems engineering work, what we were seeing was a desire to connect the architectural side of the modeling with the analytical side, the analysis and simulation stuff that we have traditionally been involved in. But really our observation was that this wasn't a technological problem. It was actually more of a communications problem. And what we see with MapleMBSE is that certainly for the systems engineer and the subject matter experts, if they have a way of being able to first of all, get information from the systems model, and then do something with it, and then be able to push that information back into the systems models without being forced to use SysML tools. In fact, without even being forced to even understand what SysML is, just to be able to do their work in an environment that they are comfortable with. So the idea here is that we can accelerate the introduction of MBSE processes by reducing organizational resistance to these new processes from subject matter experts. The SMEs then have a tool that allows them not only to collaborate well with the systems engineer, but also with each other, with different groups through the systems model. And as far as the program director or the manager that's overseeing this really is a very powerful way in order to reduce project risk and unbudgeted costs and overruns. So it really does help to reduce the sort of churn, the friction, the miscommunications, the errors that can actually cause a lot of disruption to the process. Amazing stuff. So how do we do it? So the way that we achieve this is by creating a tight, synchronized bidirectional interface into the systems model, and then connect that, and then push that through to the to Excel as the sort of the spreadsheet interface to the systems model. So what MapleMBSE is doing is allowing any structures in the systems models to be converted into tabular views into that model, and any information that is updated in the system model that is automatically updated in this environment. Conversely, any information or additions to the model can then be added into the spreadsheet interface, and then pushed back into the systems model. The critical thing here to note is that this is not Excel file import and export. This is an integrated interface into the systems model. We currently support most of the standard SE tools, Rhapsody, Cameo, Magic Draw through Teamwork Cloud, and then recently we launched an adapter for Capella. We're going to be focusing mainly on Cameo and Teamwork Cloud for the rest of this presentation. And then, in order to address the biggest challenge for us is that every task is different, every model is different, every customer does things differently. So we actually need to have a very flexible, powerful way of being able to configure these views and any kind of customization of the tools that is required for doing that. So we provide a very powerful modeling capability or configuration capability to be able to address that particular complexity. So that's really what's kind of setting the scene for this session. So now I'd like to introduce you to David. He's principal systems engineer at SSI. In that role, he provides model-based systems engineering consulting services to multiple defense and commercial industry sectors. He has extensive personal experience in designing and leading design teams for both software and hardware, covering an unusually broad range of system types. In addition to MBSE, he has a strong concentration of domain knowledge in safety, reliability, maintainability, and diagnostics. David studied mathematics at the University of California, San Diego, and received an MBA from the University of Texas McCombs School of Business. And he's joining us here from Austin. I'm sure you are enjoying a lot less snow than we are here up in Ontario. And really, that's this is just introduce you to it. And then really, what we're going to be focusing on in this particular session is really looking at how MapleMBSE can aid in the gathering of information for functional safety and cybersecurity applications. And in his brief, David did actually describe MapleMBSE as fascinating, which always gets my vote. So with that, I will pass it over to David. Maybe stop sharing.
Yeah, and just get a share here, and get my presentation up. Can we see my presentation?
Yes.
Yes. Okay. So this is our letterhead, System Strategy. As Paul introduced me, I'm a principal with System Strategy Inc. System Strategy Inc. is based primarily out of Detroit, but we have people in San Diego and Austin as well, and we serve a lot of different kinds of customers, but in particular a lot of defense, but not only defense. And yes, we are all U.S. citizens. We all have secret clearances, and so we don't have any issues working on government or military projects. This is a repeat. Paul's already introduced this, and then I'm just going to go over two things before we jump into the model and into the tool, because they're kind of important about how this all is going to work, especially in terms of safety and reliability. So the first is, what are we really trying to do with MBSE? And this I've taken out of my book, Simple SysML for Beginners. This shows a typical problem. And in this particular case, our little company is making an insurance box that would go underneath the dashboard of your car and report in real time whether you're driving irresponsibly or responsibly, and your insurance rate would go up. And we can see we have a variety of people working on this, because the box is a box that would have a mechanical engineer. We'd have a system on chip in there, cloud designers, application, but we'd also have things like data privacy experts. If this were going to work in Europe, we'd be concerned about protecting the data. We'd have ethics experts. What if the box reported that you were speeding near an elementary school? Should we call the police or not? We'd certainly have accountants trying to figure out how to bill you for it, lawyers, marketing experts. And all of these people would need to have a shared vision of the system. Because if they didn't, they would all just sort of make up their own and go off and do their pieces, and the pieces would end up being inconsistent with each other. A big problem that comes up very, very often. What I do like to point out about this, though, is earlier we were calling this single version of the truth, maybe about 10 years ago. And the problem with calling it single version of the truth is many people misunderstood that this became the universal database of everything. It's not the universal database of everything. It's really just the shared part. And that is the challenge of how to figure out what is the amount that has to be shared, and make it simple enough so that everyone can understand it, but complete enough so that we get consistency between all these different domains. And in the case of safety here, getting more specific, there are several domains here that are very related, like safety and failure analysis. Safety is not quite the same as failure analysis, but they share a lot of information, as does the reliability team, the spares logistics team, and even the cyber team come together. And there's heavy overlap, but hazards are not only because parts fail. Hazards can be caused by confusing user interfaces or weather and stuff. So the system can be working perfectly and you can still have a safety issue and so on. So this is, in fact, when we talk about this, first of all, I've just thrown out 5 teams here, but in reality, there can be a lot more. There are probably more like a couple dozen in a real complex system. I know this because I spent about 5 years with IBM building rack servers. And in our rack server team, once we kicked off a project and agreed what would be in the rack server, we had a very tight process to crank one out in about 18 months, and it took 37 different departments to make one rack server. And this is going to be something like this. We're going to have a lot of different people who all need this common view of the system. And you don't want to just dump everything. Like reliability alone has 100 different attributes. So if everybody dumps everything into the model, it can overwhelm people. So this is an ongoing challenge that the industry is still working on figuring out the right way to do this. And that's part of what we're doing here. Oh, the other thing I also want to mention, because it's important also, particularly for safety and reliability, is there are legacy specialty tools and specialty databases out there that have decades, often have decades of failure data and stuff in those tools, and we're not going to replace those with SysML. This is where the spreadsheets come in, because in many cases, either the information is directly in spreadsheets, or spreadsheets are the way to get at the information, because those specialized failure databases can export to spreadsheets. And so spreadsheets become the glue that helps us get the relevant information. And this is where MapleMBSE comes in. Okay, so that's all I'm going to do for PowerPoint. Now I'm going to go into a model. Okay, so now we're talking about how we would work on a model. And so here we have a typical model of a car, and I'm going to go back and forth. So for those who are not familiar with SysML, this would be the top level block. And here we have parts, which are usages of several kinds of other blocks. For example, the battery here. The car will have a battery in it, but that battery might be used in 7 other models of car as well. So kind of welded into the corner. More the meaning is when you go to build a car, you go to the warehouse, get a battery, and bolt it into the car. And so that's the representation we have here. So the car has these things in it, and they have functions in each thing, and then flows between functions. And these flows and these ports and stuff tend to be where the issues are for safety, cyber failures, and so on. So here, we'll jump over here. There are 2 different ways that we make elements for safety analysis and cyber analysis and so on. The first thing is, in some cases, we've got things that are just specific things that we would like to have in the model, like a hazard and a safety goal. These have nothing to do with the mechanical structure of the car. So we want to create elements for them. And in here, what we've done is we've made specialized kinds of requirements for that. There's some advantages to doing this way. And we also sometimes have relationships like we want to put in beyond the relationships that are just in SysML. So for example, here we've got a mitigates relationship so that the safety goal can mitigate a hazard. The other way, which I'll show this in a second, and then come back to the other way, which is more the focus of what we're working on today with MapleMBSE, is we have another kind of stereotype that isn't about creating a new thing in the model, but rather adding some information to a thing that's already there. And so, for example, we might have a safety part. We'll go through the model and flag parts that are related to safety and add some information about them, like the automotive safety integrity level, ASIL from ISO 26262. Or in a flow, we might be worried about what kind of flow is going back and forth. So we create these in a profile, and we use these to extend or enhance the model. So here is an example of how the hazards might work. We might create some hazards here, like an unaware pedestrian or a rear door open. And our first step in the ISO 262 process would be to identify a safety goal to mitigate the hazard. And so these would go into the model. Looking more, now we come back here and look at the structure. Here we see we've already flagged some of the part usages here as safety. Now, right now, whether this is exactly right or not is not material. What we're interested in today is that some of the things are safety parts and some aren't. In our current analysis, we have decided that transmission axle and wheel aren't particularly safety relevant. Now, that might not be what the real answer is in a car, but from a modeling point of view, this shows that we've got certain things we're going to pay attention to. And notice this extra stereotype now has been added to the part relationship for that. We also have in a flow here here we have a battery providing DC power to a starter motor, which is in turn starting the engine. And so the starter motor is flowing, providing torque over to the engine. And here, then, first of all, we've got the parts. These 2 we've decided are safety relevant. This one, not yet. So the battery we've decided is an ASIL A item, and its failure rate is something. And we've got a justification for that, and it is a safety relevant item. And similar for the starter motor. since this hasn't done that, we haven't yet decided that this is safety related. We don't have any such thing. We've also identified this as a safety connection and a flow type of DC power, and that it's safety relevant. Again, these are the specialty things going on. And here's a similar one detecting an unauthorized engine start, perhaps for security point of view, but it's not necessarily safety related. Once we get into those, the tool has a certain amount of ability to do things itself. So here, for example, we've got the relationships, the mitigate relationships now between our safety goals and our hazards. And this is more of what we are doing here with, we're going to work with MapleMBSE here. So here we have applied the safety part stereotype to these guys. Now, this is where the built-in function of the tool is not that great. Here, I'm going to lock the tool so I can edit it. This takes a second. So, okay, so it's going to lock everything. We're working in Teamwork Cloud, of course. So one of the things that happens here, if we suddenly decide that the alternator is a safety related, as soon as we start trying to edit this, it adds the stereotype to the per property, but you can't really just directly set or unset that stereotype here, not really very well. It doesn't go anywhere. There's nothing you can click on to do it. So in some cases, or maybe you can, oh yes, you can, at least you have to click through and you can remove the stereotype again. So it can be done, but it's a little hard if you're really working in spreadsheets. You can't do it by copy and paste. You've got a kind of a manual operation here. And similarly, we've got here the safety ports, and we've got the same thing where we have applied this. This you can set. It won't necessarily work by copy and paste. Here you might be able to copy and paste things in. And here we have some safety connections likewise. So this is where we then flip over to MapleMBSE, and we now have this all tuned for this. So the first thing here is we have an add-in. Yeah, and whoops. So this is one thing I've got to do here. I've got to unlock everything because demo. Because we've been working on the model. And MapleMBSE is also going to lock and unlock the model in the cloud. We're going to see that in a minute. So we don't want to compete with that. And now here we might decide that the engine is actually something we're worried about. So we just mark it there, and we can go here and we can save to the model. And here, oh, sorry, that's on another screen. And so now we come up here, we're going to say, make the apply the safety part to the engine. And we say, okay. And now it's up there. Now, when we go back to Teamwork Cloud and we look at this on the model over here, we come up here and look at the branches. We should see that. Okay, all right, a demo, all right. All right, at any rate, that will post itself up there, and that's the general idea. So this will apply, and we can commit to this thing to the server. Now, the more relevant thing here is this one here, where we would have the failure rates, and we can move this to 35, and we're going to save the model to the server. Oops, yeah, I got to pull this over the other window. Set starter failure rate. Okay. Okay, and so now here we've got to update the project. This one has not come through. For some reason, we got a little bit of a conflict there. At any rate, this would go through to the model and commit, and that's the basic idea there. So now here is the basic final idea that this is just a kind of a notional mock-up, but here would be your other source of information. So you might have a large database of part failure rates here, and they might be what you need, or they might not be what you need. First of all, they might be coming in from some other tool, and often you might have a failure rate for a larger thing like the engine, but you're just trying to work on a smaller piece like the oil filter. And so frequently failure rates in the real world, you have to provide some allocation to make an estimate of the specific failure rate for your part. This can be put in and this is part of the glue. So this would go into here, and we can absolutely connect these to it. Now, there is a little trick here in that this is actually a viewport, or this is a sync port, a sync view for the model itself. So if you paste a formula in here, what the tool does is immediately evaluate it and replace it with the number, because we're not really going to want to push an Excel formula into the model. So the way we would be working on this, first of all, we might be needing to refresh this ourselves. So the integration point, which is something SSI can help with, would be a customized Visual Basic macro that would both pull the latest data from the data source and also push it into the model from here. And that's something certainly we can get going for you. The other thing I was going to show a little bit of today was how this actually works.
Sorry to interrupt. I noticed that from the message that since there is a new revision, that's why you are not able to save to the server. If you check the add-ins and reload, and then update, now you will be able to commit the changes from MapleMBSE to the server.
So what do I need to do?
Yeah, MapleMBSE, reload or update. You will see a notification asking you if it's okay to reload. Yeah, click OK.
Yeah, so now we'll see it on the server.
Yeah, now you have to go to add-ins and save to model.
Oh, I see. Oh, now we can save to model. Okay.
Yeah, this should give you the changes.
Oh, I see here. Yep. Yeah, I hadn't quite got that path before, so it caught me a little by surprise. And now when we do here, we can update project. There it is. There's the change data that we did, right? So that's finished just showing it. Thanks, Barani, for pointing that out, right? The other thing is, how does this actually work? It took me even a little while to understand this. The MapleMBSE product really works entirely on your local workstation, and it uses a standard API to talk to Teamwork Cloud. There isn't it doesn't need a piece of anything installed in Teamwork Cloud itself. And this is here, we're not going to walk through this, but this is showing roughly how this works. For the spreadsheet, we've got the instrumentation explaining the worksheets in the workbook. And then from within those, we're identifying, and then on the Teamwork Cloud side, we're identifying where things are in the model and which things we are. And then we've got the schema creating lookup tables for each item, and then making the sync view inside the spreadsheet for that. And so this thing, it's not terribly difficult, but it does take some work. And this is part of the service we would provide to get this working. This is how we actually do the instrumentation that Paul mentioned. And this is getting this customized for, especially for defense people who are defense sensitive. This is the service that will be provided by SSI, working with MapleSoft, but we can work on your secure or confidential information and isolate that from MapleSoft and get consulting from MapleSoft generically on how to make what you need made. So at any rate, that gives us an overview of how we would be synchronizing, although this is a little bit of a mock-up, a database of legacy information about failure rates through MapleMBSE into the model. So this then is really a kind of the vision of how we do this, especially since we've got some legacy parts reliability database out there and we're pushing the number in, and we're not pushing everything in the database in, we're just pushing the thing that a lot of people need, like a lot of different people will need the failure rate. So with that, that's the overview of what it is, how we would do this, and how the tool works, and what SSI can do in cooperation with MapleSoft to make customers successful.